But it'll let me start teaching, so I guess I'll just start. So we're trying to find things like the sine of 15 degrees. And 15 degrees is not on our unit circle. However, 45 degrees is, because if I look at my unit circle, I've got 45 degrees, and sine is the y value, and at 45 degrees, the y value is root 2 over 2. Then we have 30 degrees, and I could find that. Sine is the y value, that would be 1/2. And so the sine of 15 degrees, not on our unit circle, it'd be about there. And so what we can do is, if we can't use a calculator, we can use the sum and difference formulas. And so the idea is, sine of 15 degrees, I could take 45 minus 30, because 45 minus 30 is 15, and I can find sine of that. So you guys have a formula sheet that have all the sum and difference formulas on it.
I don't get these though. Like, why is it like sine?
The premise of this is, if you have sine of u plus v, so you have two angles being added together inside of the sine, then what you can do, this formula will give you the actual answer, the final answer. And the formula says take the sine of u is the first thing in the bubble, times the cosine of v is the second thing in the bubble, plus cosine of u, the first thing, times sine of v, the second thing. So it's just a formula, kind of like, the quadratic formula will find the x-intercepts for you. Well, sum and difference formulas, if we were talking about 15 degrees, right? So if this was 45 and not plus though. So if we did 45 here minus 30, that would give me 15, right? So that means u would be 45 and v would be 30. U would be 45 and v would be 30. And then because these are on the unit circle, I can actually find these things. So then in the end, I will actually have found the sine of 15 degrees. Okay, so that's what your job a lot of times when you're doing this is to figure out what's this number and what's this number. And then it can be in radians, absolutely, and it can be in degrees. Okay, and so then once you know those numbers, then you just start plugging them in and doing the math. I'm going to go through several. Okay, so let's do our 15 degree one, sine of 15 degrees. Now that was the subtraction one. I've actually already set it up for us right here. So let's finish it. So it's going to equal the sine of 45 minus 30, both degrees. And the formula says it's sine of the first thing times the cosine of the second thing minus the cosine of the first thing and the sine of the second thing. And so this is going to depend on us using the unit circle. We've got 45 and we've got 30. Okay, so sine of 45 degrees is root 2 over 2, just using a unit circle, the y value of that one, times cosine of 30 degrees, cosine is the x value, so it's the long one, root 3 over 2, minus cosine of 45, so it's the x value of 45 degrees, that would be root 2 over 2. And sine of 30 degrees would be the y value of 30, and so that's 1/2. And to finish this problem, we actually have to multiply these together. So root 2 times root 3 is root 6, 2 times 2 is 4, minus root 2 times 1 is root 2, 2 times 2 is 4. Oh, 4. And you can actually leave it like this as your answer, or because they have a common denominator, I can put the top together. But I cannot actually subtract these square roots because they're not identical. When you have unidentical square roots and you want to multiply them, you can, but you can't when you're adding or subtracting. So if we look at another example here, I want to find the cosine of 75 degrees. Now, again, we need to look at our unit circle. It might even be useful to actually have a unit circle in front of you. And you're trying to figure out what can you add or subtract to give you 75 degrees. Now this hopefully is an obvious 45 plus 30, right? Okay, so 45 degrees plus 30 degrees. But it doesn't have to be that. You could do that you take, what is that, 135 minus, what would you have to minus? 60. So you could do the cosine of 135 minus 60 degrees and do a subtraction one. It doesn't have to be adding, or the most obvious thing. Okay, then we use our formula, and the formula says it's the cosine of the first thing times the cosine of the second thing. This one, the plus for cosine, will actually be a minus here. The sine of the first thing and the sine of the second thing. And then using our unit circle again, cosine is root 2 over 2. Cosine of 30 is root 3 over 2. I'm thinking ahead. Minus the sine of 45 is root 2 over 2, and sine of 30 is 1/2. Multiply them together, it'd be root 6 over 4 minus root 2 over 4. And you're going to notice a lot of your answers are going to seem similar to other answers. This one is identical, actually, the last one. And that's because we're on the unit circle. I mean, you're going to get the same numbers over and over again. You only have so many numbers we're working with, so there are going to be similarities. Now, one of the difficult things is when they are in radians, because when they are in radians, you have to now start thinking about adding and subtracting fractions. So if we look at the unit circle is made up of, let's see, what do we got? Pi over 6, right? And then we've got pi over 4, and we have pi over 3. Now for all of those, I can change those into pi over 12. Pi over 3, if I do that into pi over 12, would be 4 pi over 12. All right, that would be pi over 3. Pi over 4 would be 3 pi over 12. And pi over 6 would be 2 pi over 12. And so how could I add or subtract those things to get me pi over 12? This would just be the sine, and basically I could take this one minus this one, or I could take this one minus this one. You just got to pick one. So once you've committed to something, then you actually have to find it. Okay, so 3 pi over 12 minus 2 pi over 12, and actually I shouldn't write it that way. I should write them in their original form, which is, darn it, sine of 3 pi over 12 was pi over 4, minus 2 pi over 12 was pi over 6, because that's how I know I'm on the unit circle. Okay, so then I use my sine formula, because we had sine here. So we've got the sine of the first one times the cosine of the second one. In the sine, the minus is going to be a minus here. Cosine of the first one times the sine of the second one. Okay, and then we just go through sine of pi over 4, cosine of pi over 6. It's actually going to be identical to what we've done. Root 2 over 2 and 1/2. It gives me the same root 6 over 4 minus root 2 over 4.
So I accidentally took that too far last time.
Probably.
Wait, can we
I
take
thought I
that?
could actually subtract the
Gotta love it when you have a blank page, huh? Okay. Now, other things that you can do with this, it's not just that. So here we have two pieces of information. We're told about sine of u, the angle u, and we're told u is in the first quadrant because it's between 0 and pi over 2. We're also told that cosine of v, so now we have a different angle, and this angle is in the second quadrant. So what we're going to do, because we're supposed to find the sine of u plus v. So if I write that out, the sine of u plus v, the formula says the sine of u cosine v plus cosine u sine v. And so some of this we can do, like the sine of u is 4/5, so I can replace that. The cosine of v is negative 12/13, so I can replace that. But then I get to a problem because I need to find the cosine of u, and I'm only told the sine of u. So that's where this other information comes in handy. This first one was said that it's in the first quadrant. I'm going to put my angle u here. And it said sine is opposite over hypotenuse. We can do the Pythagorean Theorem and find our adjacent. So now I can do the cosine of u. Cosine is adjacent over hypotenuse, so this will be 3 over 5. Okay, then we're going to work on v. Now this one says that v is in the second quadrant. So I'll put my v there. It says cosine is negative 12 over 13. If I do my Pythagorean theorem, I'll have a 5 there. So that means the sine of v is opposite over hypotenuse. This will be times 5 over 13. And notice the y value is positive here, so that's why 5 is positive. Otherwise, I would have made it negative. now that I have that all filled in, I can now multiply. So what do we get? Negative 48 over 65 plus 15 over 65. And then add those together, I get negative 33 over 65. Okay? Okay, so we have an addition here for cosine. So eventually we're going to use the cosine formula for addition. However, I've got a bit of arctan and arccosine going on, so I'd like to replace those. So what I'm going to do is I'm going to say that arctan of 1 equals, let's just say y. So that means tangent of y equals 1. So that'll be a y right there. So this is really going to be the cosine of y plus. And then we're going to take this one and let's make it a p. Okay, so arc cosine of x equals p. So then the cosine of p equals x. So now this is really just going to be cosine of y plus p. That's really weird. I'm so sorry. Okay, so how does that help us? If we write this out now, we've got the cosine of y times the cosine of p minus the sine of y and the sine of p. Okay, so I don't know any of these things except the cosine of p I know is x, right?
And then cosine of y equals 1.
No. Tangent of y equals 1. That doesn't help me because tangent's not in my formula. So then what we're going to do is we're going to go to each of these and set up a triangle. Put y in there. If tangent is opposite over adjacent, so then the hypotenuse is the square root of 2. 2. So that means when I have cosine of y, it's going to be 1 over root 2, which if I rationalize will be root 2 over 2. Minus the sine of y is 1 over root 2, which is again the root 2 over 2. Okay, cosine now, cosine of p, I can set that one up. And cosine is x over 1, the adjacent over the hypotenuse. And then I need to do the Pythagorean Theorem. And so that'll be a little bit complicated, but once you get done with the Pythagorean Theorem, you get the square root, I didn't give myself room, the square root of 1 minus x squared. I can't write it. This is ridiculous. Okay, that right there is the square root of 1 minus x squared. So then, when I want to find the sine of p, I can take the opposite, which will be the square root of 1 minus x squared, over 1. So, I have x times square root of 2 over 2 minus,
2 minus 2x.
why does that look weird?
Looks right.
Oh, I know what I did. Okay, interesting. Square root of 2 times the square root of 1 minus x squared all over 2. You can do a couple things. I mean, you could take that 2 and because you're multiplying, you can actually multiply it. Or I think we're just going to let it be, which I'm guessing you guys are okay with.
So now,
Okay, now for proving, this actually should not be that bad. You're going to use the formula because I see that I have a cosine with two things being subtracted. So I'm going to use the difference formula for cosine. I need a new color. I'm getting tired of this guy.
Yeah, make it like something interesting.
I don't know what would be interesting to you, but that's the color I'm going with.
Wow.
So this is going to be the cosine of the first thing times the cosine of the second thing. I believe it's a plus the sine of the first thing over the sine of the, or times the sine of the second thing. Okay, remember this is a proof, so I'm ignoring this for now. I'm not going to use that right now. I am just using the left-hand side to get myself over there. So now the cosine of pi over 2 is at 90 degrees. Cosine is the x value, that's 0, times the cosine of x, plus sine is 1 times sine of x. So 0 times cosine, that'll cancel out to 0. So now I just get 1 times sine, which is exactly what I wanted. So we are done. It's really not that bad to prove with these. These are actually better than the other proof ones that Roman's working on right now.
Those are the complex proofs.
Yeah. So now here we have to solve for x. But I'm noticing that I have sine with a plus in there and sine with a minus in there. So I actually have to use the sum formula here and the difference formula here. And then it does equal 0. And because I'm actually trying to solve this, I am going to be working with this side also. Okay? So let's use our formula. So sine of the first thing, cosine of the second thing, plus cosine of the first thing, sine of the second thing. Okay, so I'm done with that one. Now I'm going on to the next one. It'd be sine of the first thing, cosine of the second thing. This is a minus one. Cosine of the first thing, sine of the second thing. And that all equals -1. And then what's really cool about this is when you have cosine of sine of pi over 4 and minus cosine of sine of pi over 4, they cancel out. So I'm just left with these two here. And there's 2 of them. So I have 2 sine x cosine of pi over 4 equals -1. And the cosine of pi over 4 is root 2 over 2. And let's see, I have 2 on top and a 2 on bottom. They cancel. So now I have the sine of x root 2 equals -1. I want to get rid of the root 2. The root 2 is not inside sine. It's actually being multiplied. So I can divide to get rid of root 2. Okay, so sine of x equals, and if I rationalize, -root 2 over 2. So now it's our job to figure out where does that happen on the unit circle. It's definitely going to be a 45, but sine is negative, so it's going to be the 3rd and 4th quadrants. So x is going to equal 5 pi over 4 and 7 pi over 4. And we're done. Another blank one. Awesome. Okay, and it looks like this page is just me doing example problems. And I'll just show them to you, and you can hit pause if you need more time to look at it. And that's it for sum and difference.
Man, I wish this class was all like this.
It's kind of quiet in here, huh?